Welcome back to N.Rajini Kiranmai YouTube channel. This video, we are going to talk about what is an algorithm. So, complete video is going to present you about algorithm definition, what are the key features of algorithm, and what are the different examples of algorithm where in this algorithm it includes a key feature of it. So, let me start with the definition of an algorithm. An algorithm is a step-by-step process to solve a particular problem or a specific task where this process is written in an understandable language. In a single slot, we are going to define an algorithm as a step-by-step process in an understandable language to solve a particular task or a problem is called an algorithm. Moving to the key features of algorithm, every algorithm has three key features. One, sequence. Second one, decision. Third one, repetition. Let us look to the first key feature that is exhibited in an algorithm. As we all know, a sequence is going to represent, or a sequence means it is going to specify a specified order, step-by-step order. Sequence means where each step of an algorithm is executed in a specified order. That means algorithm performs the steps in a purely sequential order. That means it executes the first step. After the completion of the first step, it moves to the second, then to the third, then to the fourth, and so on. The best example we have presented over here regarding the key feature of sequence that exists in an algorithm is an algorithm to add two numbers. So, if we are asked to instruct the computer to add two numbers and the language which I am presenting the instructions are in an understandable language, that is in step 1, I'll say, computer, start the work. So, second step, I'm telling, ask the user to input the first number as A. Then, in step 3, I tell to the computer, ask the user to input the second number as B. Then, in the fourth step, I tell to the computer, calculate A and B addition and save that added content into a variable called sum. And that is the reason why in a simple word I said calculate sum is equal to A plus B in step 4. Then in step 5, I tell after your completion of the calculation, then you just display or print sum. That is what we wrote in step 5. And the last step is stop. So when you have observed this example, every algorithm will have a title of where this title is going to explain what the algorithm is going to perform. That is, this algorithm is going to perform the addition task of two numbers. And every algorithm starts with a start statement and it is going to end with stop. And in between, for sure, there will be reading the data, processing the data, and displaying the data. So step 2 and 3 is going to talk about the reading the data. Step 4 talks about the processing the data. And step 5 talks about the displaying the result. Now let us move to the second key feature, that is decision. So generally, decision statements are used when the outcomes of the process depends on some condition. Like say for example, if x is equal to y, then print equal. This is a general form of a if construct, can be written as if some condition, then process this, do this. And even the decision statement can also be stated in this way. So in this point, we said if the condition is true, what to do? If the condition is false also, we are going to specify here. That is, see, if condition then, so if the condition is true, then do process 1. If the condition is false, then do process 2, which is next to else. The above form is commonly known as if-else construct. That means here it clearly says if the condition is true, then process 1 is executed, else process 2 is executed. Now let us look to the example. So in this example, we have wrote an algorithm to check the equality of two numbers. So this is the task that the algorithm is going to perform. So obviously step 1 starts and begins with the start statement. Then I'm asking the user to input the first number as A, then input the second number as B. These two steps can also be returned as input two numbers, say A, comma B. After reading the two numbers, that is A and B, then in the next step, I am going to check them, check their equality by writing this. If I'm writing the condition, what is the condition I'm doing? I'm implementing equality checking. So A is equal to B. If it is equal, what I am telling, then print equal. If A is not equal to B, then it moves to the else part and it's going to print not equal. And last statement is stop. So if the condition is true, it is going to print this particular statement which is next to then, and later it doesn't goes to else and doesn't goes to this print statement, then it directly jumps to step 5 and stops the execution. If say for example, if the numbers which I gave is 1 and 2, 1 is not equal to 2, isn't it? So here in step 4, it checks. So condition is not satisfied. So both numbers are not equal. So obviously it skips this statement and moves to else, then print not equal and then goes to stop. So this is how a decision key feature is going to be implemented. Now let us move to the third key feature of an algorithm, that is repetition. That means repetition is going to involve executing, say, one statement or sometimes more than one statements for a number of times. This can be implemented generally by using the constructs like while, do while, for loops. We call them these steps or constructs as loops. These loops execute one or more steps until some condition is true. Say for example, I have presented an example to print the first 10 natural numbers. So here, because I have to repeat the work, I am using three points. That is, for a looping variable, I am initializing, say, I is equal to 1. And where to stop the repetition, for that I wrote a termination condition for the looping variable, that is I less than or equal to n, where n value is 10. Why? Because my task is to print only 10 natural numbers. And then there should be an increment and decrementation work based on that looping variable. And for that I have done incrementation I is equal to I plus 1. So three contents are sure to be used to make any steps to be executed repeatedly. One, initialization. This is the thing. Second one is termination condition. And then third one is increment or decrement part. So every looping statement like while loop or do while loop or take for loop, in all these loop statements, for sure these 3 points will be there. That is looping variable initialization, termination condition return on a looping variable, and lastly increment and decrementation work done on the looping variable. So see here how it is going to work. So algorithm begins with start. I have initialized saying I should be 1, and I said because the task is to print 10 natural numbers, I gave n is equal to 10, or directly you can write I is less than or equal to 10 here. Then in step 3, I said repeat steps 3 and 4 until I is less than or equal to 10. So what it's going to do, it prints one I. So because it is initially 1, 1 is printed. Now I becomes 2, and it checks whether 2 is less than or equal to n. Why? Because we said the steps should be repeated, right? And finally, it is going to stop over here. I'm See here, I just wrote some mistake over here. So this is repeat steps 4 and 5 until I is less than or equal to m. Hope it's clear for you. Thank you for watching this video.